Hello viewers, I hope you're all doing well. Welcome back to channel Ingenious Mac Tech. Today we are starting our second half of our manufacturing process course. This is the part where we study the machining processes. In the previous section, we will discuss about the changing of shape or deformation or like these kind of things. but in this but from today onwards, we will discussing about the machining processes. That is, in other words, removal of material. Theory of metal machining. This is chapter theory of metal machining. In this, we will cover overview of machining technology, theory of chip formation in metal machining, force relationship and the merchant equations, power and energy relationship in machining, and cutting temperature. Without wasting your time, we will continue. Material removal process includes a family of shaping operation, the common features of which is removal of material from a starting work part so that the remaining part has the desired shape. Categories is machining, the mechanical material removal by sharp cutting tool like turning, milling, drilling, etc. Abrasive process, mechanical material is removed by hard abrasive small particles like grinding. Non-traditional process include energy forms other than the sharp cutting tool to removal of material. Machining. In the machining process, the sharp cutting tool is used to cut the material and leave the desired shape. This is the initial, this is the final. Cutting action involves shear deformation of work material to form a chip. As chip is removed, the new surface is exposed. This is the initial. When the cutting tool is moving in this way, the chip is removed and the new surface and the desired surface is come into the existence. This is the direction of motion. This is cutting tool. This is the rack angle. We will discuss the terminologies later step by step, but this initially you can see that this is the rack angle alpha, this is the flank, and this is the cutting edge. This is the work part, the original surface. The motion of the chip is in this direction, and this is the shear deformation to form a chip. This, if it is moved here, the negative rack angle, and this is known as the relief angle, and this is cutting edge. Why the machining process is important? As the industrial revolution and growth of manufacturing come into existence, variety of work material can be machined, most frequent applied to metals, variety of part, shape and special geometries can be made, screw threads, accurate round holes, very straight edges and surfaces, good dimensional accuracy. In this machining, the tolerances can be up to 0.025 millimeters. It's very small value. Excellent surface finish, roughness less than 0.4 microns. Disadvantages. There must be some disadvantages, as everything has some disadvantages. Waste full of material. There is too much waste. Chips is generated in machining are wasted material. Time consuming. It take more time than the other processes such as casting and powder metallurgy. Machining in the sequence, generally performed after the other manufacturing process like casting. Machining is done after casting or after forging or after bar drawing. Other processes create the general shape and of the starting work part. Machining provide the final shape, the dimensional finish, thus finishing and specific geometry details, etc. Machining technology. Machining is not just one process; it's a group of processes. All the processes use a cutting tool to form a chip. Cutting tool is in common, but of separate shapes. And relative motion is required between tool and work. If there is no relative motion, there is no cutting. This relative motion is achieved by means of primary motion called speed and a secondary motion called feed. The shape of the tool and its penetration into the work surface combined, and with these motion produce a desired shape of the resulting work surface. We can discuss speed and feed later. There are some machining operations. There are many kind of machining operation like which capable of generating a certain part, geometry and textures. Most important machining operations include turning, drilling, milling. These are very much important and the base of all others. And other machining operations are shaping and planning and broaching and saving, etc., sewing, etc. We will discuss as step by step as we go on. Now, first we discussed about turning. What is turning? Turning is a single. It involves single point cutting tool removes a material from a rotating workpiece to form a cylindrical shape. This is some limitations that it can be performed only on cylindrical shape, the turning process. Speed motion is provided by rotating the work. When work is rotated, this is known as speed, and the feed motion is given to tool. The tool is moving with some feed. This is known as feed. This is speed and this is feed. And this is the turning tool that is rotating on some machine, and this is the feed, and in this way the material is removed. Drilling. Drilling is used to create a round hole, usually by means of rotating tool drill bit. that has two cutting edges. In drilling process, the cutting tool has two cutting edges. This is rotating with very high speed and the feed is given in this direction and the hole is produced. Milling. Milling is rotating multiple cutting edge tools. In this, the tool has multiple cutting edge. It moves slowly relative to work to generate plane and straight surface. The speed motion is provided by rotating cutter while the direction of the feed motion is perpendicular to tool axis. In this, the speed is very much high. Two forms of milling, peripheral milling and face milling. Peripheral milling is the milling in which the perpendicular of axis of rotation is parallel to the surface. But in face milling, the axis of rotation is perpendicular to the surface to be worked, to be processed. Cutting tool classifications, it includes single point tools, one cutting edge, multiple cutting edge, more than one. These are not a big deal. Yes, this is single point cutting tool. This is multiple point cutting tool. Cutting conditions. Relative motion is required between tool and work to perform a machining operation. This is condition number one. The second is cutting speed. Primary motion V is primary motion. Feed is F and it is known as secondary motion. Depth of cut is the penetration of tool into some work part. VFD are collectively, it is a combination that is dependent upon our choice and our tool or material and all of these factors. But VFD are collectively called as cutting conditions. For certain operation, material removal rate can be found as MRR is equal to VFD. Material removal rate is equal to velocity or maybe known as speed, feed and depth of cut. Cutting condition for the turning is this is the depth of cut, this is cutting speed V and this is feed as we move in this direction. Roughing and finishing. Machining operations usually divided into two categories. In production, several roughing cuts are usually taken on the part followed by one or two finishing cuts. Roughing remove large material and it is fast operation, creating shape close to the desired geometry but leaves some material for the finish cutting. High feeds in roughing, the feed is high but the depth is also high but the speed is low. In finishing, completes the part geometry, achieve the final and exact dimensions, exact tolerances and exact finished. In this, the feed is low, depth is low but the cutting speed is high for the finished. Machine tools. A power-driven machine that performs a machining operation include grinding, function machining, holding work part, position tool to relative work, provide power at speed, feed, depth, etc. Orthogonal cutting model. This is a cutting model of formation of chips. This is the tool when it will move in the direction the chip is formed. This is T naught. This is alpha rake angle. This is initial. This is the thickness, but this is thickness of chip. As you see, it is increased. Why? This is because of ductility or the deformation. This phi is known as the shear angle, and TS is the shear thickness. LS is the shear length. As this is clear that oriented at the angle theta phi. This is and alpha is the rack angle. Chip thickness. Chip thickness ratio. The position of cutting tool below the original work surface corresponds to the thickness of the chip prior to the chip formation. That is the T naught. As the chip is formed along the shear plane, its thickness is increased to TC, as I have told you before from the figure. That this is small and this is large. R is given by T naught by TC. This is chip thickness ratio. And it is always less than 1 because TC is always greater. Determining shear plane angle. It is given, we can determine in the following steps. First of all, R is written as from the trigonometry of the chip formation, L as sine of phi divided by L as cos of phi minus alpha, shear angle and rake angle. Now tan phi can be written as R cos alpha divided by 1 minus R sine alpha. We can shift tan here and the phi can be determined, or R can be determined by changing the locations of the terminologies according to given conditions. This is the serrated chips. We can discuss it later, but this is the thickness of plate and tool, and this is the rack angle, etc. Shear strain, gamma. Shear strain in machining can be computed from the following equation. Gamma is equal to AC by BD, AD plus DC. These are some terminologies. We can finally conclude that gamma is equal to tan phi minus alpha. Tan shear angle minus rack angle plus cot of shear plane angle. These are the terminologies named. This is actual chip formation. tool is moving here. This is the secondary shear zone where it can some shearing planes. This is chip. This is effective angle. This is primary shear zone, secondary shear zone. These are some conditions. There are four basic type of chip in machining. The formation of chip depend on the type of material being machined and the cutting condition of the operation. There are four basic type of chip can be distinguished. There is number one, discontinuous chip, number two, continuous chip, number three, continuous chip with built up edges, BUE, built up edges, and the number four is serrated chips. Discontinuous chip is like the segmented chips, breakage, stopping, or like this kind. Brittle. This can be done in the case of brittle work material. If, for example, cast iron, when there is low cutting speed, large feed, depth of cut is high tool chip friction, when the friction of tool and chip is high, and large feed depth promotion. These are some conditions on which the discontinuous chip are formed. Irregular surface, and there is a fact that there is irregular surface due to chip segmentation. Second is continuous chips. It is in the case of ductile material, high cutting speeds, small feeds, sharp cutting edge, and low tool chip friction. And this can give us good finish, and this is like completely smooth chip and known as continuous chips. Continues with built-up edges. This can be done in can be happened in ductile material, low to medium cutting speeds, tool chip friction, maybe some kind of high built-up formation is cyclical. It forms then break off. It form and then break off. This can be done. This is known as built-up edges. Some particles on the of a new surface. This is the chip. In this the chip is always continuous, but there is some edges. It reduces tool life and cause rough surface. Serrated chips. This is the term that I have used before. In this semi-continuous sawtooth appearance, this is like sharp edges. This is high shear zone. This is low shear strain zone. This is high shear strain zone. So these are four types of chips. Forces in metal. There are some force applied against the chip by the tool. Against the chip by the tool can be separated into two mutually perpendicular components. Friction F for the chip along the rake face, the normal force to the friction is N. Friction F and N is R, resultant is R, and is oriented at the angle of B, called the friction angle. This is the shear force RS, and normal to this is Fn, and their resultant is RS, and Fn is R prime. Now you can visualize in next. Yes, force acting on chips. Friction force F and normal force to friction N. Shear force Fs and normal force to the shear is Fn. This is force, friction force. This is N normal to the friction. This is their resultant R, and this is alpha rake angle, and this is the angle between R resultant and the N normal, and this is beta. This is the shear force. This is normal to the shear force. This is R prime, the resultant of these twos, and there is an angle that is not mentioned here. These are the same things I have told you. Yes, coefficient of friction is given by mu is equal to F by N. Friction angle related to coefficient of friction as mu is equal to tan beta. Shear stresses is given by S is equal to shear force by shear area, where and AS is given by T naught, initial thickness, W width, sine phi. This is again the same thing, not important one. Yes, this is important equations. Forces in metal cutting. Equation can be derived to relate the force that cannot be measured to the friction that can be made. As from all the upper formulas, the conclusion is the F is given by Fc sine alpha plus Ft cos alpha. N is equal to Fc cos alpha, Ft sine alpha. Fc cos phi and Ft sine phi is equal to Fs, and Fn is equal to Fc sine phi plus Ft cos phi. Based on these calculated forces, shear stresses and coefficient of friction can be determined. The Merchant equation is the equation of all possible angle at which shear deformation could occur. The work material will select a shear plane angle phi, which minimizes the energy. This is for the minimization of, or to reduce the energy, that is given by phi is equal to 45 plus alpha by 2 minus beta by 2. This is derived by Merchant based on orthogonal cutting but valid to 3D machining, and these are based on some assumptions, so it is approximation, not the exact. What Merchant equation tell us? It gives a real value of Merchant equation is defined the great general relationship between rake angle and tool chip friction and shear plane angle. I have told you generally that it is for the angle to reduce energy. When the higher shear plane angle means smaller shear plane, so the lower shear force, and the vice versa. When angle is high, this is smaller shear plane, which means lower forces, and in this the high forces. Power and energy relationships. The power to perform machining can be computed from PC. Cutting power is equal to cutting force into speed, cutting speed. In the horsepower system, it can be divided by 33,000. Similarly, gross power is given by PC by E is the modulus, E is the mechanical efficiency of machining tool, and in horsepower it is given by HPC by E. HPC is the horsepower of cutting horsepower. Similarly, PU unit per unit power is given by PC by MRR, and in the horsepower system, HPC divided by MRR. The unit power is known as specific energy U, and these are some interrelations of the thing. You can see it by yourself. Specific energy is not inconsiderable. These are some horsepower. You can see it by yourself if you have need, but this is not important. These are some examples. You can done it for your practice, like in a machining operation, blah blah blah. These problems can be solved by using the formulas that I have told you in the all above slides. You can see there, and you can, if you have done it, you can comment me, and I will send you an email or any kind of contact. You can send the answers to me if you have done it. I hope it is very easy numericals that you have done. Cutting temperature is approximately 98% of energy machining is converted into heat. Then the temperature is must maybe over 600 degrees centigrade, and the remaining energy 2% is retained as elastic energy in the chip. Cutting temperature. Cutting temperature is approximately 98% of the energy is machining converted into heat. Tool is the temperature is maybe over than 600 degrees centigrade. The remaining energy is used in elastic energy in the chip formation. Cutting temperature. Several analytics methods used to calculate cutting temperature, but the major is method by Ann Cook, derived from dimensional analysis using experimental data for various work material. T is equal to 0.4 U divided by rho C VT naught by K into the power 0.333, where T is the temperature rise. U is the specific energy, V is cutting speed, T naught is chip thickness, rho C is the volumetric specific heat of the work material, and K is the thermal diffusivity of the work material. Cutting temperature. Experimental methods can be used to measure the temperature in machining. Most frequently used technique is the tool chip thermocouple. Thermocouple is used. Using that method, K trigger determine the speed temperature relationship to be out of the form. It is given by T is equal to KVM, where T is the mere tool chip interface temperature. The parameter K and M depends on cutting conditions other than V, because V is here, and these are the some cutting conditions. This is the simplified relation. If the initially cutting speed is low, temperature is low, but if it is high, the temperature is rising slowly. This is for the stainless steel, and this is for the some free machining steel. Here and that's all for the theory of metal machining. It's basically the initial and the start of the second section, the second half of the machining manufacturing process. I request you, my viewers, to do the all the problems that I have shared with you in my lectures and all of the other things. So kindly do it by yourself and share your answers with me in the comment box. And if you have solved it on some kind of paper, you can tell it to me, send it to me. It is for the benefit of the others. And also, if there is some kind of ambiguity, you can ask in the comment section. I will reply you. And finally, I say you that please subscribe and like and comment. Comment is if you have any queries, but like if you like it, and subscribe for more informative and interesting and lectures of the manufacturing process. I hope you understand. We will meet you in the next video. The next video is about machining operation part 1. This is theory of machining. Next is basically the metal machining part 1. See you in the next video. Till then, take care.